Dear students, now we are going to see the subject transmission lines and RF system. Under that, the topic is waveform distortion. On completion of this waveform distortion, the students will be able to describe the frequency distortion, differentiate phase and frequency distortion, derive the condition for a distortionless line. Waveform distortion. In an ideal transmission line, the signal through the transmission line when the input signal or the sending end signal is not same at the receiving end, then the signal is said to be distorted. The distortion is to be classified into two types: frequency distortion, delay or phase distortion. Frequency distortion. The attenuation constant alpha is a function of frequency. The signal transmitted along the line will be attenuated to different extent. For example, the voice signal consists of many frequencies will be transmitted along a transmission line, and all the frequencies will not be attenuated equally along the transmission line. Hence, the received signal is not exact the replica of the input signal at the sending end. Such a distortion is called frequency distortion. So, alpha is equal to root of Rg minus omega square Lc plus root of Rg minus omega square Lc the whole square plus omega square into Rc plus Lg the whole square by 2. Phase distortion, beta is equal to root of omega square Lc minus Rg plus root of Rg minus omega square Lc the whole square plus omega square Rc plus Lg the whole square. Okay, the velocity of propagation V is equal to omega by beta. So the phase distortion is also depends on a frequency. Thus, the velocity of propagation V also varies with frequency. So, some of the signal reach the receiving end faster, while the some waves will be delayed than the other, will not have the same transmission time. Thus, the receiving end signal is not exact replica of the sending end signal. This kind of distortion is called phase distortion or delay distortion. Distortionless line. There should be a condition for a line to become a distortionless. So the distortionless line does not distort the signal phase but does introduce a signal loss line. They are not superconductors. This is known as heaviside distortion. So alpha is equal to root of Rg minus omega square Lc plus root of Rg minus omega square Lc the whole square plus omega square into Rc plus Lg the whole square by 2. The value must be made independent of frequency by making Lg plus Rc equal to 0. Derive the condition for distortionless line. Z equal to alpha plus j beta. Y is equal to gamma is equal to alpha plus j beta. Gamma is equal to propagation constant. Y is an admittance which is equal to G plus J omega C. Z is the impedance that is equal to R plus J omega L. The propagation constant gamma is also equal to square root of Zy. So gamma is equal to substitute Z and Y. So R plus J omega L into G plus J omega C. Multiply this term. Gamma is equal to root of Rg plus J omega Rc plus J omega L G minus omega square Lg. So Rg minus omega square Lg plus J omega into Rc plus Lg. To make the frequency independent, equate the second half to Lg plus Rc equal to 0. Substitute this condition in equation 1. So gamma is equal to root of Rg minus omega square Lc plus J omega into 0. So gamma is equal to Rg minus omega square Lc. So minus 1 equal to J square. Substitute in number value. So root of G plus J square omega square Lc. So gamma is equal to root of Rg plus root of J square omega square Lc. So gamma is equal to alpha plus J beta. So alpha plus J beta is equal to root of Rg plus J omega root of Lc. Alpha is equal to root of Rg, beta is equal to omega into root of Lc. Whether the phase velocity get varied. phase velocity equal to omega by beta. So that is equal to omega by beta is equal to omega root LC. So phase velocity is a independent of frequency, which is equal to 1 by root LC. The phase distortion can also be called as delay distortion. Thank you.